Hello again. We're going to continue our discussion on solubility today. And if you remember our last video, we were looking at saturated and unsaturated solutions and how that relates to solubility. So we're going to continue that. We're going to look at model 1 here, which has 3 different solutions, and all of them are at the same temperature, and all solutions were stirred and let sit for 3 hours. And then we have here in experiment 1, you're adding it to 10 grams of water, experiment 2, 20 grams of water, experiment 3, you're adding it to 50 grams of water, and we're doing 10 trials for each of them. Okay? And you're adding varying amounts of the solute. 1 gram, then 2, then 3, etc., up to 10, and you're doing that for each of the water quantities, 10 grams, 20, and 50. So let's answer some of these questions. Identify the variables that were controlled. Temperature, 20 degrees Celsius, and time stirred. Those were not changed. What variables were changed purposely? So that would be the amount of water, and also through each of these, okay, down each of the different experiments where you are changing the mass of the solute, the amount of solute that you're adding to each of the quantities of water. Number 3 says, what experimental question can be answered by analyzing the data in the 3 experiments in Model 1? Use the words solvent, solute in your question. So basically we're looking at, as you change the amount of solvent, by increasing the amount of solvent, will you be able to dissolve more solute? That could be a question that you might be asking, okay? Because the amount of water is what's changing here as you compare experiment 1, 2, and 3, and you're trying to see, are we going to be able to dissolve, is more solute going to be dissolved? The saturation level, is the saturation level going to increase if you have more water, more solvent? Okay, so you can write that out. In each of the 3 experiments in Model 1, determine the point in the experiment that the beakers became saturated. Draw a box around the entire section of data in each experiment that represents saturated solutions. So where did it become saturated? If you remember from our previous video, we did a graph. And that graph showing the saturated amount as you add more and more kept going up and up and up, and then all of a sudden it flattened out. That flattening out portion is where you have reached your saturation point and you can no longer dissolve anymore. So let's see where that is the case here. Well, notice we add increasing amounts of the solute, and the amount that dissolved here all of a sudden flattens out, and we have a maximum right there. 3.6, you're never going to get above 3.6. Over here in experiment number 2, when we have 20 grams of water, we have maxed out right there at 7.2. So once you get past there, you're never going to be able to dissolve more. And over here, we have, notice they're not adding by increasing amounts of 1, 2, 3, 4. They're adding by 3, 6. They're counting by 3s here. And we are maxed out at 18, right here, 18. Okay? Which experiment shows the largest mass of dissolved solute in the saturated solutions? So that would be experiment number 3. Propose an explanation on why the mass of dissolved solute changed among the 3 experiments. Well, you have increasing amounts of water. Increasing amount of water is going to allow for more and more solute to be dissolved. Alright, here it says read this, so let's take a second and do that. It just says that solubility is a measure of the maximum amount of solute that can dissolve in a given amount of solvent at a specific temperature. Basically, you're saying how much can you dissolve in a given amount of water at a given temperature. And usually it is measured per 100 grams of water, or whatever the solvent is. So if you can dissolve 20.4 grams of sugar in 10 grams of water, then obviously that's not 100 grams there. You have to multiply everything by 10. That's 204. That's equivalent to 204 grams in 100 grams of water. Okay? Would it be acceptable for a student to use trial 2 from experiment 1 to determine the solubility of the solute in model 1? Well, let's go back up here. Let me just see. We're looking at trial 2, model 1. Trial 2 in model 1. Trial 2, could you use this here? Well, if you look across trial 2 and all of these actually, they have not become saturated yet. You have to wait until they're saturated to determine the solubility. So you have not reached the maximum amount yet. So no, you could not use trial 2. In any one of those, you could not use trial 2 yet because not yet saturated. You haven't reached the maximum amount yet, and solubility is a measurement of the maximum. In Model 1, none of the experiments used 100 grams. Use complete sentences to explain how the ratio, grams of solid per 100 grams of water, can be calculated from the data given in Model 1. Well, you're just going to multiply by a certain factor, just like we did up here. I just kind of mentioned it. Let me just use this example. If you've got 20.4 grams of your solute, in our example here it was sugar, in 10 grams of water, and you want to find out how much solute is that going to be in 100 grams of water, you can just set up a proportion. Well, obviously 10 times 10 gives me 100, so I have to multiply this by 10 to give me 204 of the solute. That's how you can use a quantity other than 100 to find out what the saturation is, and then use a proportion to write it per 100 grams of water. Use the data in Model 1 to calculate the solubility of the solute at 20 degrees Celsius for all 3 experiments. Let's show the work. Okay, so let's see. Let's go back up here. We have maximum amount is 3.6 in 10 grams of water. Here it's 7.2 in 20 grams of water. Here it's 18. Is that right? Yeah, 18 in 50 grams. So we're going to use each one of those and then use the proportion. Use a proportion to make sure we write it per 100 grams. So in experiment 1, it was 3.6 grams in 10 grams of water, and then it was 7.2 grams in 20 grams of water, and then it was 18 grams of the solute in 50 grams of water. Well, we need to write it and find out how much that is per 100 grams of water. So I just multiply this by 10, that would be 36. Here, to get 100 grams of water, I'd have to multiply by 5. 7.2 times 5 is also going to be 36. And then here, I'd have to double this because I want 100 grams, not 50. 18 times 2 is going to be 36. So you see here that even though we use different amounts of water, they had different saturation levels. In other words, different amounts were able to maximize the amount that could be dissolved in those water quantities. But solubility, the solubility is the same when we measure it per 100 grams of water. Okay? It says circle the word or phrase that best completes each of the statements below. When the volume of solvent, this would be your water, increases, the mass of the solute, that would be like your salt or your sugar or whatever, that can dissolve in a saturated solution, is going to increase. If the volume increases, if you add more and more water, then you can dissolve more and more of the solute. Okay? By the way, I think, let me just clear this up here. What I'm saying is, as you add, as your volume of your water increases, you can dissolve more and more of the solute. But don't be confused. Once you've saturated it, you can't dissolve anymore, right? it gets saturated at different levels, 3.6 for the first one, 7.2, and then 18. Once you've saturated it, you can't add any more and dissolve anymore. But more and more water allows you to dissolve more and more of the solute. Okay? So the increase in volume is going to increase the amount of solute that you can dissolve. When the volume of the solvent increases, the solubility of a solute at a given temperature is going to be the same. The solubility amount never changes. How much can you dissolve per 100 grams of water? That's a constant number for that particular situation, for that particular solute in that solvent at a particular temperature. Okay? So don't get too confused. What they're trying to show you is, yes, up here in our different trials, we had different amounts that were able to dissolve, but that's because we had different amounts of water. If you convert all of these to per 100 grams of water, you would have 36 on all of the experiments. 36 as your amount that would be your saturation level. Okay? So in experiment 3, trial 9, 18 grams of solute dissolves, whereas in experiment 1, trial 9, only 3.6 grams of solute dissolves. This is what a student is supposedly saying. Obviously, the solubility is greater in experiment 3. Well, we already kind of debunked that, because 3.6 grams per 10 grams of water is equal to 7.2 grams per 20 grams of water, which is equal to 18 grams per 50 grams of water. All of those ratios are exactly the same to 36 grams for 100 grams of water. That is your solubility. Okay? Calculate the mass of the solute used in Model 1 that is needed to make a saturated solution in 140 grams of water without leaving any solid solute at the bottom. Okay, so basically what we're saying is we had 3 experiments where different amounts of water were used, 10, 20, 50, and all of those can give us the correct solubility value. We just are going to convert it to 100 grams of water and change the numerator accordingly. Now it's saying, well, what if you had 140 grams of water? No problem. We could use any one of these ratios. Let's use the solubility ratio. 36 grams will dissolve in 100 grams of water. If I've got 140, then I'm solving for X right there. And you can do that. All you have to do is take 36 times 140, divide by 100, and that is going to be the value you're looking for. All right, extension questions already. This was kind of a short video. Model 2 is showing solubility curves. Let's just analyze this for a second. We're looking at temperature on the x-axis. We're looking at solubility here. And look how it's measured. Grams of solute per what? 100 grams of water. And we have 2 different substances. Notice that as the temperature increases that direction, your solubility looks like it's increasing. Remember, solubility was measured at a specific temperature. Now what they're saying in our extension questions is, hey, what if the temperature changes? What happens to solubility in general? There are exceptions, but in general, look what happens. Goes up. According to the graph in Model 2, what is the solubility of substance A at 30 degrees Celsius? We do this, 30 degrees Celsius. We go up to 30, we go to the curve for substance A, and we read that across. It is about 50. Now that is about 50, approximately 50 grams per 100 grams of water. That's how much you're going to be able to dissolve in 100 grams of water, maximum amount. Describe the trend in solubility for A and B in Model 2 as temperature increases. As the temperature increases, solubility is going to increase as well. It's not a linear increase. It is a little more of a curve like this. You might call that somewhat exponential, but it's not really a linear, straight linear relationship. Okay? If a saturated solution of substance A here, in 100 grams of water is cooled from 30 to 10, what mass of solid solute would crystallize out? Oh, that's a great question. If a saturated solution, you have 100 grams of water, and it's saturated, and you are at 30 degrees Celsius and then go down to 10. So if we're at 30, and then we go down to 10 here, look at the difference. It goes from 50 grams being able to stay dissolved in that 100 grams of water down to 20. So if you cool down your solution, you're going to see some of those particles coming out of solution and turn into crystals, turn into solid crystals and settle at the bottom of your container. So you're going to have the difference here. You're going from 50 down to 20. You're going to have 30 grams that are going to crystallize out. Okay? If a saturated solution of substance B this time in 50 grams of water at 30 degrees Celsius is warmed to 50, what mass of solute would need to be added to make the solution saturated again? Be careful, we're only working with 50 grams this time, okay? And we're going to go from 30 to 50. So let's look at substance B. We're going from 30 to 50. B is here, up to here, and I'm just going to approximate these values, okay? So at 30 degrees Celsius, saturation level is 30, and then at 50, saturation level is about 50, but this is per 100 grams of water. So we're going from 30 to 50 per 100. We're going from 30 grams per 100 up to 50 grams per 100. So that means if we're only working with 50 grams of water, not 100, we're going to have to divide this in two. So we're only going to be able to have 15 grams, and then up at the new temperature, you can dissolve as much as, divide that by 2, 25 grams. So if you are saturated here and then increase the temperature from 30 to 50, now you need 25 to make it saturated, so you have to add another 10. So because it's asking how much do you have to add. You have to add 10 grams of the solute in order to get it back to saturation. Okay? Alright, that one was short and sweet, just kind of a little add-on to the topic of solubility, and I hope that was helpful. We'll see you in the next video.